First of all, welcome to all of you, and thank you so much for being here with us. Before going to start my topic, I want to clear that what was the objective of organizing this workshop before doing our practical work in this course. So, the main objective of this workshop was to familiarize the participant with the GIS application, model, and the data collection tools before commencing to the practical analysis and ensuring a solid foundation for the effective utilization of the GIS technology. That you have to keep in mind that what are the models, what are the data tools that we are using in GIS. So it will be easy for you people that practically when we are going to implement these tools, so it will be easy for you people. So that the purpose of the workshop was that. Okay, my topic of presentation is the leveraging the GIS for effective environmental monitoring and conservation. You know that environment is very, very important for us. Leveraging GIS Geographic Information System for effective environmental monitoring and conservation involve using the geospatial technology to analyze the data, visualize, and understand the environmental data. So it's very important that we know about the environment and what are the application that we are using in the environment to monitor the impact of these parameters. So environmental monitoring applications that cover the areas, these are the land cover classification and change detections, habitat fragmentation analysis, water quality monitoring, air quality monitoring, climatic change analysis, deforestation and forest degradation monitoring, wild tracking and the habitat analysis, the soil erosion and the sedimentation monitoring. So these all are the environmental aspects that we can monitor through the GIS and remote sensing. What are the tools which we have to use in monitoring of the these sector of the environment? Remote sensing and the satellite images, GPS and the field data collection, spatial analysis and modeling, geospatial data visualization, map algebra and the spatial autocorrelations, network analysis and the routing, web GIS and mobile GIS. These are the techniques, these are the tools which we have to apply to monitor the environmental impact assessment. Now, this is very important. Before going to monitor the environment, we all know about what is environment. And all of you know that what is environment in a very common and a very general definition of the environment, that everything which surround us is called our environment. And what are these everythings? These are the biotic and the abiotic component. These are called the everything which surround us, that is called our environment. So environment is divided into three factors, that is physical, biologicals and the cultural. Is it clear? Okay, thank you. So the environment is divided into two major components, that is the biotic and the abiotic. Biotic component, that's the biological component, including the flora, fauna, and the microbes, that microorganisms. And we are mostly focuses in these two, that is the monitoring through the GIS and remote sensing. These are called the abiotic component, that is lithosphere, hydrosphere, and the atmosphere. And also we have to monitor the culture side, the social activities, the political activities, and the economical the growths of the countries, and all of these factors through GIS and remote sensing. This is the human nature that always we have to discuss about the um, monitor the nature's dynamics to mitigate the risk from the humans and natural activities, ensuring for the sustainable development or for sustainable benefits. So first of all, we know for the to know the nature's dynamics, what are the impact of the human activities on the natures, and mostly the impact of the human on the natures are negative impact. They are deteriorating the nature in different form, like if they are doing gaseous emissions from industries, from the vehicles, and from the different purposes. If they are deforesting, the deforestation, degrading the plant, degrading the mineral resources, and deteriorating the natural resources. So these are the issues which occur in the environment, and these issues are monitored through the GIS and remote sensing. So these are the different issues. I think there are 12 major issues in the globe. These are called the global environmental issues, and okay, we have to analyze the different parameters which are present in our environment, that is air, water, soil, and the biotic component. What are the objective of the monitoring? Monitoring of the environment may be undertaken for a number of reasons. In general, monitoring is done in order to gain information about the present level of harmful or potentially harmful pollutants in discharge to the environment, within the environment itself, or in the living creatures that may be affected by these pollutants. These definitions can be expanded as follows. The basic objective of the monitoring these global environmental issue is generally that we are doing this for our benefits. We protect our environment for us. We protect our environment for the sustainable development. We protect our environment for the healthy life. So the monitoring of these parameters, these global environmental issues are very, very important for remediations and for mitigations these problems, these issues. Monitoring may be carried out to assess the pollution effects on the man and his environment in order to identify any possible cause and effect relation between the pollution concentrations and the health effect, climatic change, etc. For example, I will give you example of the global environmental issues. If we have to identify the global environmental issue, we are going in to mitigate, to investigate, and to analyze these global environmental issues by three methods. The first one step is called the causes of the issue. When we have to find out the causes of the issue, then we have to monitor the effect of that issue on environment. And another one very important object, that is called the human. So first we have to analyze the cause of the global environmental issue, then we have to investigate the effects, what are the effect of this issue on human and environment, and the third one step is called the mitigation measurement. So in between these steps, we are doing the monitoring system through the GIS and to the field data to evaluate the pollution interactions and the pattern, to assess the need for the legislative controls and emissions of the pollutant, and to ensure compliance with the emission standard. That's very important that we make all of these emissions, all of these issues to make and to balance with the permissible exposure limit, that to protect our environment and to protect the human beings. Environmental monitoring methods. There are three steps or three methods through which we are going to monitor the environment. The first one is the ground based sampling and measurement. The second is the model based monitoring. And the third one is called the satellite based monitoring. Environmental monitoring through satellites. Through satellites, how we collect the data. So there are different types of the satellites which are used to collect different types of the data from the land. from the environment, from the atmosphere. Satellite sensors and the instrument. Optical sensors are used measure reflected radiation which are coming from the sun. Infrared sensors are used measure the thermal radiation. Radar sensors are used to measure the surface roughness and the moistures. Hyperspectral sensors are used to measure the detailed spectral informations, and the lidar sensors are used to measure the atmospheric and surface properties. You know what is in our atmosphere? It is a layer which is surrounded, which envelop the earth. Okay, so that is called our atmosphere, and it is a mixture of different types of the gases, the water droplets, and that is present in the form of humidity. Satellite based environment monitoring areas. What are the areas which we covered through the satellite remote sensing? These are called the atmospheric monitoring, air quality monitoring, climatic change studies, resource management, glaciers and the snow, flood and drought management, land use, land cover, weather predictions, hazardous monitoring, aviations, agriculture, marine and phytoplanktons studies, dust and storms. So these are the areas which we have to cover through satellite based monitoring. Now come to the types of monitoring. There are two types of monitoring on the basis of environmental monitoring. The one is called the source monitoring, and the other one is called the ambient environment monitoring. What is monitoring? From the name, it is indicated that there must be some source through which we have to monitor, which causes deterioration, which causes emissions, which causes pollutions, which causes damage in the environment, which causes damage to the humans. So that is called the source monitoring. Identification and characterization of the main source in urban area, determination of the mass emissions rates of the pollutants from the particular sources, and assessments of how these are affected by the process variations. Evaluations of the effectiveness of the control device for pollution abatements. Evaluations of the compliances with the statutory limitations of the emissions from the individual sources. So these are called the source monitoring, that from where the emission occur, what are the sources. Maybe you called it the primary sources of the pollution, primary sources of the issues which are accelerated in the environment due to human activities, or maybe it's a natural activities. These are the source monitoring stations. Ambient environment monitoring. Monitoring the environment may be carried out for a number of reasons: mapping the concentration of the pollutant in the environment, identification of pollution sensitive zones, identification of possible sites for the environmental monitoring stations, tracking progress toward the national quality standard, attainment, and the emissions reductions. Serve as the basis for the modeling of predicted pollutant concentrations in the ambient environment, provide input for the human health risk assessment. Um, why it is important that we have to monitor the ambient environment that mostly consists of the gases which are present for the humans, for their good health, for the health of the flora and fauna. So that is very important that we have to make all of these pollutants, all of these emissions according to the environmental quality standards. If the permissible exposure limits to these pollutants are within the permissible limits, so the environment are safe and the human are safe and their property are safe. Ambient environment monitoring includes the pollution monitoring, water pollution monitoring, sediment, soil and biological monitoring, noise level monitoring. Now, the first one, which causes the environmental pollution, this is one of the pollution which is considered the biggest pollution, which causes a lot of diseases in human and environment, and which are mostly responsible for the climatic change. So first we have to discuss about the air pollution and air pollution monitoring, how we have to do the air pollution monitoring through GIS. As we all of you know that what is air? Air is basically a mixture of gases. There are different types of the gases which are present in the air in this specific concentration. If the concentration of the gases that is present in air that are present in the manufacturing of the air, if it is increases or decreases beyond the limit, so this air is called the air, polluted air. So, air pollution is the introduction of the chemicals, particulate matters, or biological materials that causes harm or discomfort to the humans or other living organisms, or damages the natural environment and into the atmosphere. So, if the any contaminant, any exceed or permissible exposure limit of the gases are present in the air, so that air is called the polluted air, and that air deteriorate your environment, deteriorate and damages your atmosphere. Air pollution systems from the source, it is emitted, emission started, goes to the atmosphere, air concentration is destroyed or changed or deteriorated, and depositions loaded occur, so it causes your environment, your atmosphere deteriorating, degrading or damaging. Component sources of the air pollution way natural sources. The natural sources of the air pollution are also there are two main sources of the air pollution. One is called the natural sources and the other one is called the anthropogenic sources. Natural sources are further divided into three types. Two types. One is static source and the other one is called the mobile source. What is the static source? That is the industries, the commercial areas and the housing and residential area, that is called the status anthropogenic. Sorry, the anthropogenic sources are divided into two. One is static and the other one is called the mobile source. The static are the industries, commercials and residential area which emitted the emissions to the environment, and the mobile sources are divided into three, that is train, aeroplanes and the boats, that is causes the air pollution to the environment. The natural sources that included that causes air pollution, these are called the volcanoes, dust storms and the thunderstorms that causes the air pollution. Volcanic activity is how you have to monitor, how you have to analyze the volcanic activities, that is through the landsat satellites. Storms, that is one of the meteorological activities and it can be monitored through the meteorological satellite, that is you shown in the image. Sources of air pollutions, I think it's not necessary. We have to discuss these. These are the sources of air pollutions and how we have to monitor these air pollution sources through GIS and remote sensing. The second component, atmospheric processes. Atmospheric processes are responsible for transportation, mixing physical and chemical transformation of the pollution. The wind, speeds, and direction decides how quickly the pollutants will be dispersed and what will be the direction of the impact. The vertical temperature profiles of the atmosphere decides about the vertical mixings and the turbulence in the atmosphere. This is it was the potentials of the image from the space platform to track the hurricanes and other weather systems that leads to the first operational use of what we now call earth observations by the remote sensing. This is one of the image that is taken through the satellite image from the platform. This is about the hurricanes, which give you the informations about the intensity of the hurricanes. And in 1960, the U.S. NOAA, National Oceanics and Atmospheric Administration, launched the first civilian satellite specifically to photograph the Earth on the regular basis in order to provide the data for weather forecasting. So the first satellite was made in 1960 by the US NOAA to give the information from the satellites in the form of the photograph for the weather forecasting. These satellites, called the TIROS, the Television Infrared Observation Satellites, was the first of the TIROS NOVA weather satellite that provide daily images of the globe, those that are seen in our daily TV weather forecast. uh, all of you know very well about the weather updates, and the weather now satellite are uses to collect the information from the satellites and give it to the land through images and through the data about the weather forecast. Both polar orbiting satellites such as the NOAA and the geostationary satellites such as the uh, GOES and the meteosats are used routinely nowadays for the weather forecasting. The first application of the satellite remote sensing of the aerosols. Aerosols are the particles, are the elements, are the chemicals which are present in your air as a pollutant. So there are the satellites, the first satellites which was used to collect the data from the air about the aerosols. That was the AVHRR Landsats and the GOES instrument to observe the desert particles over the oceans. All three of them were used to obtain the information about the aerosols, primarily over the water. You know that these satellites having a specific sensors in these satellites which collect the data about the aerosols from the air. Satellite remote sensing of the tropospheric trace gas began in 1978 with the launch of the TOMS instrument on board the Nimbus 7 satellite. The TOMS instrument was aims to determine the stratospheric O3, that is ozone, volcanic SO2, sulfur dioxide, tropospheric O3, uh, and ultraviolet absorbing aerosols. And this is the satellites which is used, which is to detect the information, which censor the data from the stratosphere and from the troposphere. Stratosphere, that is the upper layer from the atmosphere, which have ozone layer to protect the earth from the emission of the different types of radiations. So how we know about the ozone layer depletions, how we know about the health of the ozone layer, and so this all informations we have to get from the this one satellite. And about the tropospheric emissions, if the ozone is present in the troposphere, the layers in which we are present, that is called the troposphere layer. So if the ozone is present in the tropospheric layer, it is called the toxic ozone, poison ozone and damaging ozones, that is toxic for human health. So all of these element concentrations are monitored through the TOMS. This is one of the image which give you, which show you the different thermal infrared images acquired on the 27th September 2007, the Celsius temperature scale. It show you the temperatures of the Earth. How to monitor the total stratospheric ozone through satellites. Image from the trials NOVA weather satellite also contribute to public concerns over the state of the environment. This is the trials and the NOVA satellites are used to sensor the conditions to the molecule of the ozone in the stratosphere and give the data to the satellites. Some international weather satellites that are using geostationary, these are called the geostationary satellites, and which are used to collect the data from the satellite from the terrain and give you the information about the weather. So these are the international satellites which are used to collect the data. Satellite in Pakistan for weather detection. There are different satellites that are used in Pakistan for the detection of the weather. That is PAKSat 1, Pakistan Communication Satellite. For weather forecasting, the PRSS 1, Pakistan Remote Sensing Satellite, provided by the multispectrals and the photometric imagery. Now, That was the air pollution. What are the satellites which are used to monitor the air pollutions and how it display the data in the form of images. That all was about the air pollution. Now come to the water pollution, because water is the universal solvent and it is very very important. Without the water, life is impossible on land. Now, what is water pollution? Any undesirable change in the concentration of the original water composition, that constitution and composition, that is called the water pollutions. There are different sources of the water pollution. One is called the point source and the other one is called the non-point source. Point sources are those sources from which directly the water is polluted. These are called the point sources. Non-point sources are those, like I will give you the example of the irrigation, agriculture activities. If you are using the pesticides, if you are using the fertilizers to fertile your land, fertile your soil, and that water, pesticides, that fertilizers degrading your soil environment, degrading your soil quality, and that penetrate into the water table. So indirectly, or through the floods or through the water, through the irrigation system, that soil goes to the any water reservoir, so it polluted the water indirectly. So the non-point sources are called the indirect sources of water pollution. What are the effect of the water pollution? Why we have to monitor, why we have to study about the water pollution, and why we are using to collect the data to monitor the water pollution through GIS. So it is very very important for the benefit of the human, for the benefit of the environment, and for the for the sustainable development. We are doing this effort. So the water is affecting, it causes the waterborne diseases. It's also causing some HIV diseases in human, like the hepatitis B and C and A. That is because of the water pollution. It degraded the environment, it degraded the soil quality, it degraded the crop quality. What are the sources of monitoring of water? Apart from the monitoring of pollutant in the liquid effluents, simply may be carried out in rivers, lakes, estuaries, and the seas in order to obtain an overall indications of the water quality for rainwater, groundwater, and the runoff water, particularly in the urban environment, to assess the influence of the pollutant sources. A point where the water is taken from supply to check its suitability for a particular use, using the sediments and the biological samples in order to assess the accumulations of the pollutants and as indicators of the pollution. Apart from the measurement of the chemicals and physical parameters, the quantitative and the qualitative assessment of the aquatic flora and the fauna is often used to give a holistic view of the presence of the or absence of the pollutions, and well recognized relationship exist between the abundance and the diversity of the species and the degree of the pollution. This is often used to assess the cleanness and the natural fresh water, that is called the biological monitoring. This is the way how we have to monitor the water quality, the water quantity we have to use. These are the water sources, and these are shown in image. What are the water quality parameter that's related to the environmental sciences or the chemical sciences? So you can show all of these parameters. There's the physical parameters, chemical parameters, and the biological parameters on the map to show the quality of the area for your study. What are the water quality standards? Water quality standards serve as the foundation for the water quality based approach to the pollution controls and are fundamental component of the water management. If you don't know about the quality of the water, if you don't know about the national environmental quality standard which is declared for the water quality, so you can't show that this water is polluted water or this water is the healthy water or without pollution or fresh water. So it is very important before mapping, before modeling, before analyzing And before monitoring, first of all, you must know about the quality standards for water. And for every environmental issue, you must know the quality standard. Remote sensing for water resources, that for monitoring of the water quality, we have to do the remote sensing. So what are the process, how the steps we are doing the remote sensing? The overall application of the remote sensing in the GIS in water resources sector can be broadly categorized as below: snow and glacier mapping and monitoring, irrigation, water management, flood disaster monitoring, forecasting and management, water quality monitoring, watershed management, groundwater prospecting, environmental impact assessment. And these are the areas through which we have to monitor the area through remote sensing. Water quality. The water quality depends on the dissolved organic matter, how much, if they are above the permissible exposure limit, so the water quality is bad. If the dissolved organic matter are within the permissible exposure limit, so the quality of the water is good, and it is shown through an image like this. How to show the suspended sediments in the water? It is shown through a graph. A significant relationship between the suspended sediments and the radiance or reflectance from the spectral waves band, or the combinations of the waves band, or the satellites and the aircraft sensor have been shown using in situ studies, concluded that wavelengths between 700 and 800 nanometer were most useful for determining suspended sediments in the surface water. If the suspended material is the suspended load is present in the water, in the surface water, so if you are using the satellite image, which is the wavelength of 700 to 800 nanometer, so you can determine the suspended sediments or suspended load in the surface water. How to detect the glaciers and the snow? The snow cover build-up and the depletions can be detected and monitored from a variety of remote sensing platforms, glacier lakes, and then easily identifiable on multi-spectral satellite data of the median resolution from 24 to 30 meter of fine resolution, that is 6 meter. Clouds and snow about areas appear similar in standard XCC images, which is solved through the SWIR band response, in which snow covered area has low reflectance. Measure sensors used for snow cover mapping are NOVA, AVHRR, Modis, Aqua, Terra, and these Landsat and the Astros and Scores and the resources are the satellites which are used for mapping the snow cover. Now, flood is one of the area which we have to cover with the water monitoring. So how to cover the flood area, how to monitor the flood area. These are the satellites and images which is used to cover the flood monitoring and flood management area. How to do the flood management? This one is called the prepared stage. In the prepared stage, chronically flood prone areas have identified that these area when how to chronically flood area declare the flood areas, calculate it or show it to people. You can investigate these area from history, study from history, that if these areas are the found areas for the floods, so you identify it as the risky area. So this is the preparedness, relief and rescue during flood affected areas, flood damage statistics, updations of floods, conditions in the terms of flood, residence and the persistence. Floods, mitigations of the floods. That are the preparedness in before the flood and after post-flood effects or post-flood mitigations. So change in river course, river bank erosions, drainage congestions, and the flood risk zone. These are the required themes which you have to show on the map for the flood monitoring or management. What are the remote sensing? How to do the remote sensing for the flood area using the historic satellites? Remote sensing data acquired during the flood. It is possible to provide the chronically flood area in the form of a map showing severely affected, occasionally affected areas. Flood monitoring and forecast can be done using the hydrodynamic models. The hydrodynamic models are the land use, soil type, the the soil moisture, rainfall, biological satellites, and the GIS and the POS and the SAR and NOVA and AHVRR. The statistic data, the drainage basin, and the size of the drainage system you can show on. You can collect this data through the remote sensing. Using the flood inundations models in the GIS environment, optimum evacuation plans can be generated for carrying out rescue operation. That is really important. If you know about, if you have the map of the area, if you have know the peak points, if you know the damages and all of these things about the floods, it will be very easy to access that area or control the disasters. During the flood, a flood map showing the spatial extent of the flood affected area, flood damage statistics like the district-wise flood affected area, submerged groups, moorland villages, and the length of the submerged road trail can be provided. Satellite data can be used to regular intervals for the updations of the flood condition, continuous floods monitoring. So this is very important that how you have to use the GIS and the remote sensing for during the floods and during any disasters. During mitigation phase, what you are doing during the mitigation stage using the high resolution historic and the present satellite data, mapping of the river configurations and the flood control works and studies of the bank erosions can be carried out. Using multi-date satellite data, it is possible to demonstrate the drainage conjunctions area in the chronic flood prone areas. Flood hazards and the risk zone maps can be generated using the multi-year satellite data acquired during the floods. So during the mitigation stages, what you have to do first, you have to using the historic data, the historic resolutions and present satellite data, and you have to compare these two and configure the flood control works. This is the flood damage to standing crops, how they have to this is the image of 17 July 2006, how it damages the area. This is pre-flood and this is the post-flood affected area which affected the cropland. How to find out the ocean temperature from the satellites? For this monitoring, for this investigation, we are using the NOVA satellite. Through NOVA satellite, it sensor the surface temperature of the oceans, and that you have to get the data about the oceanic temperature. Now, how to monitor the soil, because soil is one of the important parameter of the environment, which give the health to the environment, which give you a healthy food, which give you a healthy environment. And this is a very important thing. If you have any one of the global environmental issue, for example, you have air pollution, so that global environmental issue accelerate another one issues, and that another one issue accelerate another one issue. So keep in mind that one environmental issue accelerate thousands of environmental issues. If you have soil pollution, if you have a deteriorated soil, if you are unhealthy soil, so it will affect your air, it will affect your water, it will affect your food quality, it will affect your environmental health. So this is very important to monitor the quality of the soil. So for this purpose, what we have to do, sources of the soil pollution, there are different sources that maybe you have to divide it into the natural sources and the anthropogenic sources. The natural sources of the air pollutions are the soil pollution, are the debris or the plants, dead organic matter which is present in the natures. And the anthropogenic sources, the biggest source that is thrown to the environment is the solid waste, which is humans are responsible for that soil pollution. And agriculture activities, agriculture practices are also involved a lot in the soil pollution. Deforestation, degradations, and nuclear fallout, water logging, salinity, soil acidification, other biological agents like the decay of the natural or plants, flora and fauna. So it causes the soil pollution. Effect of the soil pollution on land. What are the effects of the soil pollution on land? It will degrade the quality of the soil. If it will affect your agriculture, it affect your crops, it affect your whole ambience environment. Effects of the soil pollution on land, on this is the same that affected the biological agent like the fungi, spores, toxins, bacteria, and other pass into the soils by waste and animals and humans, and causes the diseases like cholera, typhoid, mycosis, and the tetanus. That is called the tetanus is because of the polluted soil. The earthworms and the hookworms and the roundworms are also produced, which affect the human health and the appetite. Toxic substances from these dumps leach out of the percolates through the soil layers below the contaminated the groundwater. If all of these toxins, all of these chemicals, all of these pollutants percolate to the soil layers below, it will contaminate your water table that is present in your ground. What are the remote sensing? How remote sensing is used for soil mapping? Remote sensing techniques has reduced the field work to a considerable extent, and soil boundaries are more precisely delineated than the conventional methods. While mapping the soil using the RS, the stereo data is highly useful in identification of the different landforms which have got close relationship with the soil associated with them. The stereo data from the pan camera, a broad spot, IRS, IC, enables the delineations of the physiographic units and the soil maps derived there from the in a better way. So these are the methods. This is the remote sensing to collect the data of the soil. This is the flow chart which show you how to make a map of the polluted soil through GIS using the ArcGIS software. How to monitor the water logging and the salinity in the soil by using the GIS. Due to the improper management of the soil and the water resources in the commands area, the problems of the salinity and the water logging are reported to be on the increases. Information on the nature extent, spatial distributions, and the temporal behavior of the area under water logging and salinity is essential for proper management of the irrigated land. This is very important for the growth of the crops and for the good vegetations, that you have to monitor the soil, if for the parameter of salinity and for water logging, because in these two conditions the soil is unable to grow to give a fertile plants. So for this purpose, the sensor are used are the Landsats and the IRS and the LISS. These are the sensors which are used to collect the data about the salinity and the water logging. Soil erosion. What is soil erosion? Soil erosion is the process of removal of the superficial layer of the soil from the one place to another place. And what are the environmental impact of the soil erosion? So, that the top most fertile soil is called the fertile soil. If it is removed, so the fertility is removed, and it is one of the bond which make the other soils bondly compact. So the soil erosion is one of the environmental issues which affect the health of the soil, and alternately it indirectly it affect the crops and the vegetations which is present on the earth surface. Now, how to do the soil erosion modeling? Quantification of the loss is an important application that several researchers attempted using the GIS. The general approach, including the rule-based approach, where the several parameters that influence the soil loss are weighted and summed to the assess the final index to rate whether or not a particular area is eroded. In another approach, the absolute value of the models are derived from the maps, and the soil loss is calculated using a physical and empirical model. These models are used to this is another one approach. Through this way we have to calculate the soil erosion intensity. This method gives the physical quantity of the soil loss. Some important parameters which influence the soil loss are the slope, vegetation cover, soil erodibility, rainfall quantity and intensity, soil conservations, and management factor. So, to through this modeling, we have to investigate these parameters. Universal soil loss equation. This is one of the equation which is used to calculate the universal the soil loss or soil erosion. Role of remote sensing in land slide mapping. If in the earlier lecture, in the earlier presentations, you learn a lot about the landsliding and all of these activities. Uh, Comprehensive landslide inventory is a prerequisite for the landslide hazards and the risk analysis. The landslide inventory map not only shows the time and the date of the occurrence, but also the types of the landslide. Landslide inventory involves the landslide distribution analysis, landslide activity analysis. The landslide inventory involves in these steps. The first one is the landslide distribution analysis, that in how much area the landslide occur, and the other one is the landslide activity analysis, that in which ratio, in which concentration the land is sliding. These are the images which show you the landslide activities. These are the satellites. These are the satellites which are used to detect the landslides activities, and which is involved in the mapping and include the shaded relief images and produce the light detections of the ranging of the area. Land use and land cover change, how you have to monitor the land use and the land cover change through the satellite image. So for this purpose, we are using the land set the TM images to detect, to monitor the land use and land cover changes. How to monitor the deforestation from the satellites. So for this purpose, the satellites and other satellites are also used to detect the data about the deforestations, because forests are very very important for the health of the environment and for the health of the biodiversity which is living in the forest. So the forest monitorings for the healthy environment, for the healthy world, and the world free from pollution, that is very important because forests are the best sink for the carbon dioxide, which protect your environment from air pollution and your soil from erosion, also from landsliding, and also protect the floods, because the roots of the plants absorb a lot of water during the monsoon season. During the rainy seasons, it absorbs the water and it protects the land from the flooding. How to monitor the noise pollution? This is very important because we don't consider the noise as a pollution, and we don't emphasize that noise is how much toxic, how much deteriorating the environment, and uh, how much it deteriorating the human health. So it is very very important that we have to monitor the noise pollution to advanced methods. So the advanced methods of the noise monitoring is called the GIS and remote sensing method. Um, that noise is defined as the unpleasant or disagreeable loud sounds or sounds without valuable that causes discomfort to the listener. Any sound with the loudness above the then the 80 decibel, or if you are working, if you are studying in a daytime, this concentration is 85 decibel. If the noises are, or the sounds or the voices are above the 85 decibel, it is considered as the noise. Sources of noise pollution, same as with the other pollution, it is also divided into natural and anthropogenic sources. Natural sources, the thunderstorms and the earthquake, and the man-made sources are the industries, machineries, construction equipments, non-industrial automobiles, and the aircraft, generators, markets, loudspeakers, railway station, and all of these are the man-made sources of the noise pollution. What are the effect of the noise pollution? As I earlier told you, that it affected the humans and the environment both, and also the biodiversity which is present in your surrounding, it which is in the area which is resistance to the noise. So it affect the both population and environment too. What are the control of noise pollutions you can do? You can measure different measures to control the noise pollution. For example, if you are sitting in a room, in a classroom, so you can use the curtains and the carpets to reduce the effect of the noise pollution without use of any machinery, any equipment. And another way, if you are living in a rich populated area, so you have to grow a lot of plants. So plants are the best sensor for the noise pollutions. It sense, it absorb the noise pollution, and it reduce the intensity of the noise in that area. So that is really cheap and the natural and the phyto remediation to control the noise pollution. Now come to the our topic, that monitoring of the noise pollution through the satellite using the GIS. Noise pollution monitoring through the satellites is an emerging field, leveraging remote sensing technology to track the noise pollution. And these are the satellites which are used to monitor the noise pollution. The satellite based sound level measurement measure the sound intensity using the satellite borne microphones. Infrasound monitoring detect low frequency sound that is below 20 hertz using the satellite based infrasound sensors. Aircraft noise monitoring track the aircraft noise using the satellite based radar and the acoustic sensors. Road traffic noise monitoring estimate the noise level using the satellite based traffic monitoring. So these are the satellites which are used, these are the sensors which are used to monitor the noise pollution from the satellites, from the space, or it give you data. The satellite sensors that are on missions to collect the noise pollution, that is NASA, European Space Agencies, NASA Jet Propulsions, and the ESA. These are the satellites which are on missions to collect the noise pollutions from the terrain from the land. What are the noise pollution monitoring applications where we are monitoring the noise pollution? Because we know that in an urban area, the noise pollution is increasing because of the high level of the population. So, urban noise mapping. Airport is one of the mobile source, one of the static source. It is both of the mobile and the static source for creating the noise pollution. Airport noise monitoring map, industrial noise monitoring, traffic noise monitoring, environmental noise assessment, and noise pollution health studies. In the environmental noise assessment, this noise is called the white noise. White noise, it included all type of the noises that is coming from the urban, airport, industries, from the traffic, from the social gathering, from the events. So all of this noise is called the white noise, and which affect your environment, your health quality, and your environmental aesthetic. So to protect our environment, to protect the human health, to protect the property, we are doing the noise monitoring. This is one of the image which show you the areas, the urban areas which have a high level of the noises. These are the again the satellites which are on the missions to protect, to collect the data uh, of the environmental parameters from the satellites. These are the layers which representing these different environmental parameters in the form of images. Now come to the final part, the last part of our topic, that is the conservation. How we conserve our environment. First, we have to identify the global environmental issues or environmental issue. After the identification of the issue, we have to start the monitoring of that issue by different methods, by using the satellites images, by using the field data, by using the remote sensing tools. After that, we are going to the conservation planning and management. How to conserve the natural resources, how to conserve the biota, how to conserve the flora and fauna which is present in your environment, which give your environment a healthy environment. So conservation planning include the habitat restoration and prevention. Habitat of whom? Habitat of the wildlife habitats or human habitats which are affected by the environmental issues. Species distribution modeling, that you have to do the species distribution modeling in the wildlife. Ecosystem service valuation, conservation priority setting, protected area management, sustainable land use planning, climatic change mitigations, and adaptation. These are the sectors which we have to plan, we have to manage for the conservation purposes. Benefit of the GIS in environmental monitoring and conservation. What are the benefit of the GIS? Improve data accuracy and efficiency, enhance the spatial analysis and visualization, inform decision making, increase collaborations and stakeholder engagement, better resource allocation, effective monitoring and evaluations, scalable and transferable solution. These are the importance of the GIS, why we are using the GIS in environmental monitoring, because we can monitor the environment through different methods. So GIS give these benefits for the protection, for the conservation of the environment, for the conservation of the natural resources, and for the protection of the biota which are present in the environment. What are the real world example which are working to protect the environment, for the conservancy of the environment and for the natural resources? The nature conservation planning atlas, the WWF World Wide World Fund for GIS based conservation planning, NASA Earth observation for climatic change, ISRI green infrastructure planning, the global forest watch. These are the real example which working on the basis of GIS to monitor all of these environment and natural parameter which is present in the environment. Benefit of the environmental monitoring and use of the GIS, again the same, the global coverage, high temporal resolution. This is the one of the most important factor because we are living in a very economic vulnerable area. So the cost effectiveness really means to us. So it is cost effective and the consistent data improve the decision making. What are the challenges when we are monitoring the environmental parameters through GIS and through remote sensing? So these are the challenges: data quality and validations, spatial and temporal resolution, atmospheric interference sensors, calibrations, and data integration and analysis. This is the last save the earth to bring the word and for the new birth. And why we have to do all of these? This is for the purpose of sustainability. You know what is sustainability? That we have to enjoy the natural resources. We have to enjoy all of the benefits, but we protect these benefits for our future generation too. So that is called the sustainability. Thank you so much. If you have any question.
Hello. Assalamu alaikum. Can everyone hear me? Okay, my name is Mohammed Ismail Khan. I'm actually a research assistant at the National Center of Excellence in Geology, University of Peshawar. And thank you so much, madam, for presenting this crucial knowledge about the GIS applications in environmental monitoring and conservation. So, few things I want to know about the groundwater perspectives you have mentioned. I think that was the slide 38. Can you please bring that slide back if possible?
Okay, okay, I will do. This is water pollution.
I think that was slide 38, if I'm not wrong.
38, 33, 4.
38, I think.
30th.
Yep, yep. 38, 38,
Okay,
38.
38, right. This.
So, is there any specific techniques or like the satellites through which we can map these groundwater perspectives? Like, I mean, how can satellite contribute to mapping the the hidden things? I mean, that thing is much crucial. I mean, if you can bring some light on these points.
Yes, I can. I will explain you through example that how to we have to sense the groundwater data through remote sensing, and we have to show it or we have to monitor it through the remote sensing.
How? I mean, how we can do that? Hello.